Thank you, Sharon. Hello, everyone. Welcome to our Snack and Learn webinar, Unleashing Digital Power to Revolutionize Structural Analysis. I'm Cecilia, and this is my colleague, Dr. Dino Chen. We are so glad here to have the chance to talk about our unique software and other API. So here is a little bit about our background. We are a part of the digital development team in Hong Kong and currently working for all the stream of business to support their projects with BIM and also digital twins. We also work on the R&D and the BIM standard checklist and guideline with different government authorities. We are a team of structural engineers, MEP engineers, interior designer, and programmers. Both Dino and I are structural engineers, and Tony is MEP engineer. We are passionate about transforming the engineering workflow and hope to drive the adoption of the digital solutions starting from day one of the project cycle. And one of our aim is to streamline our daily design, working at the daily workflow by leveraging our technology to enhance efficiency and accuracy, and as well to improve our collaboration within the team. And we have to help our engineer to equip, adopt, and evolve in digital transformation too. And our invention have recently gained Silver Award, also the most popular award and an honorable mention in Hong Kong BIM Automation Arena 2023. And today we will start with our expertise, which is structural engineering. So, okay, here is the agenda. To start with an introduction of ETE, our self-developed software, and how it can help WSP engineers, BIMers, and our draftsperson. We will then explain one by one under the series of ETE, that is our digital revolution. We will also share with you our current challenges in developing this software. And then we will talk about our future planning of other development. And at last, we will have a Q&A session. We have a lot to share today, so let's get started. So what we are going to introduce you today is our self-developed structural tools called ETE. It's a series of software including structural analyze, session analyze, foundation design, and the drawing automation that helps our structural engineer to obtain the best solution and automatically generate the drawings within just a few clicks. The current ETE analyze can be one on Eurocode, Hong Kong code, China code. So with our ETE, it helps to minimize the calculation time, the communication time between the engineers and the draftsperson, as well as the modeler. It also reduces the production time as well. In the past, we used to start with ETABS and Excel to analyze the loading behavior, and then we enter the load into other detailing software as a complete set of calculation. And at last, you will draft the framing and RC details and pass to somebody for 2D CAD or 3D model. So all includes back and forth communication, which can take ages. But since the development of BIM is fast growing, and most of our engineers start the draft directly using Revit, and then work on collecting the loads in ETABS. With our ETE, you can also start with modeling the framing in ETABS and use the ETE to obtain everything. You start with either way, it works too. It's particularly useful when you have multiple amendments because ETE can read the test file from ETABS or with the file directly without any alteration. You can already have the detailing design, the design report, 2D drawings or 3D modeling in a very short time. This all can be done by the engineer itself, himself or herself, although it may still need the BIMer or draftsperson to touch up further because different authority require different format for the submission. But in Hong Kong, ETE has already incorporated different authority templates. So you can just pick any one of them before the drawing generation. It generally saves a lot of time for the preparation or data processing. And by how much time that can be saved, we will let you know soon. We hope that ETE is here to help you to give you more quality of time. So the engineers have more time to pay attention for the safety issue, and the BIMer or draftsperson can have more time to focus on other aspects, not just working on 2D or 3D stuff. Here you can see that there are 26 BIM users as suggested in Hong Kong by the Hong Kong Construction Industry Council. Actually, our BIMers or draftsperson have a lot of chance to involve in our digital transformation by working on this aspect. So it may sound very complicated, but we do have a few videos to show you how it will be transformed in a very short period of time. So please stay tuned, and I will now invite Dr. Dino Chen to talk about the series one by one. Thank you.
Oh, thank you, Cecilia. I'm trying to explain the ET system. ET system is including structural analysis and design tool we call ET structural, and we have some small tool for complex section analysis called ET section. This two part is for structural analysis, and we also have the another tool called ET foundation is for foundation design. So in according to Hong Kong Wing Code, it's very complex, especially the calculation of the wing load. So we invent ET Hong Kong Wing is a tool for compute the complex wing load according to Hong Kong code. It's considered the shelter effect. So we need the building information around the project to calculate the wing load. And we also have the ETE GI infantry, which can direct connect to the Hong Kong CSDI. We call it the common data bank of the GI data bank. So we can use this data to form the geotechnical information. For example, have some bore log information or the rock profile for our foundation design. Recently, we have some tool called ET Railway. It's a BIM automation tool, can produce the railway model in BIM format and in Revit program. All we call ETE. This is the whole system. We just want to have a BIM integrate tool for engineer to make the design easy and reduce production time. So we focus on the structural design first. Structural design in Hong Kong is very complicated procedure from the prelim design to the final construction stage design. At the very beginning, nowadays we have the CSDI data bank. The Hong Kong government provide all the AGS file of the data bank of the GI data to provide to the public. So we invent a GI infantry to connect this data to direct transfer this data to the GI data. We can use this GI data to form the rock profile and the soil property. And we use the ET foundation to capture this data to transfer the foundation model to save file. Another software is belong to CSI. This program can run a lot of different types of foundation analysis. We use this program to produce information to our in-house software called ET Foundation. Use this ET Foundation, we can produce foundation drawing, Revit model, and the foundation calculation sheet. And this part is for foundation. And the other part is structural analysis. We have the ET tool. I will show you in video, but I just introduce the basic function of ET nowadays. And the ET can generate the model from ETABS model, and they also can gen the model to Revit. Also, Revit, you can use the Revit model to gen the model to ET, and all the model can can transfer between different software based on ET. And ET, we have the user graphic user interface for user to input very complicated information like the BIM mark, column mark, and the BIM column information. Is much more complicated than nowadays the ETABS model. And the other one, the ET, by the ET calculation, they can run the graphic analysis, and they can directly output the design report of every component like beam, column, and shear wall. Also, they can generate the model to ETABS or if the model you just run in ETABS, you can use ETABS to capture to run the graphic analysis or window analysis and transfer the low internal force data to ET, and then let ET to run the member design, like the beam column design, and then generate the report for our submission. Nowadays in Hong Kong, because the member mostly likely is designed based on Hong Kong standard, so we already get the approval for the Hong Kong Building Department to approve all the calculation is correct. And this is the whole process. So use this graph is very convenient to show how to transfer the model from ETABS and transfer the model to the Revit. Usually some project, we have some very talent engineer, they can build ETABS very fast. So we can use ETABS to build a model and transfer to ETE. And sometimes we have some Revit model from the architecture. So we can use Revit to build a model. Both is okay. Now also ETE can transfer the model to our Hong Kong standard design software called SES. Also, the ET can combine a lot of function, a lot of plugin from the AutoCAD. So we can generate a lot of drawing, such like structural framing and the RC detail drawing. Also in Hong Kong, each element like column, beam, and shear wall or slab, they also need an individual calculation report for each member. So we can use ET to generate all the member design in PDF. And this is spend a lot of time if we don't use ETE, we need to run a lot of Excel to produce this calculation. Nowadays, we use ETE can automatic calculation, even optimize, and then we generate the final manual design report. And because we need to integrate with BIM, so we already developed some plugin on Revit program. Is write by C#, is embedded plugin, or also in Revit they call add-in. This add-in is based on an ETE theory. It can generate a lot of different member from ETE. And also, if we have the Revit model, they can generate the model to ETE to run the other analysis. And this is the BIM integrate function of ETE. So I have some video to show the whole process. You can see this video. At the very beginning, we just import the ET function. Sorry, this one here. We have the Revit model, we can transfer to ETE. In ETE, we have our in-house software, so we have the GUI is graphic user interface for like a 3D interface also, and we can input a lot of information. Also, if we have the ETABS model, we can import to ETE and then import to Revit model. So it's both ways okay. And the other function is very powerful for our submission is the design function, including the RC detail and the framing design. And this, for example, I take a very simple frame structure. Now this function is generate the framing drawing. It just need one click. It could generate the framing drawing in the certain format. And the other one is the beam. For example, this one is the column RC detail is generated from the result calculated by the ETE. And also this is the most complicated is the beam RC detail. In Hong Kong, we need to draw the beam elevation and the section. So we use ETE to produce this complicated beam elevation. All the data, the rebar area or the rebar length area is come from the calculation. It is matched together. So this is the combined model, the single source of the output. Yeah, because if there's the real structural model, it will have a long time to generate this drawing. So I pick up a very simple one. So take one project to just estimate how many time we can save for one project. I take a hospital project. In this project, we need to produce 460 pages for the RC beam detail drawing because every beam you need to draw elevation and the section. So we need a lot of manpower to produce one. But if we use ETE, we can cut out like the 85% of the hour. We reduce the 4,000 hour to 240 hour. And this is very efficiency for our drawing production and the calculation production. And this is the project we use ETE to run the analysis, or sometimes run the design, or sometimes it just produce the RC detail drawing, including the high-rise building and the long span and some frame structure. And this part is the introduction of the ET structure only. And nowadays I have another introduction of other software including in the ET system. One is the ET section. This is a powerful tool which can run a very complex section like the composite section analysis. Can run a lot of, you can draw the section in AutoCAD and can generate the 3D PMM curve. Nowadays, this function is already embedded in the ET structure, so you can use the ET program to analyze the complex section. And the other one is the ET foundation. Is connect to the software like ETABS or the ET. They can generate the column and wall force, and then you can import to ET foundation. Also, we have our graphic user input, and according to Hong Kong code, we need to build the pile spring for each pile. It's a very complicated model in SAFE, so we use ET foundation to generate the model to SAFE. So, and we can use ET foundation to optimize the pile length, and we can import the soil property and or the rock head profile from other software. And this is GI Infantry. GI Infantry, just mentioned before, is connect the open data from the Hong Kong government to provide the geotechnical information for the borehole they dig before. So we can connect this information for our foundation design or the slope analysis. You can see that they can generate the CAD drawing directly. In the future, maybe we can generate some Revit model for the bore log or the rock head profile. And the ET railway is a recently development item. Is for our railway model automation design. When we have the station line and the alignment line on the MTR section, including the MEP arrangement like the pipe duct and the cable tray and the conduit and the other equipment like electric equipment or the handrail, you can put all this information in the section and they are assigned different properties, especially the spacing or the how many equipment you need or in 100 or 1,000 meter, and this information all can be assigned in our graphic interface, and we just click the model will generate the whole MTR tube. This is also combined with our Revit add-in. Okay. And Hong Kong wind load is very special because it's a local wind code. We need to consider the shelter effect, to consider especially the high-rise building we're surrounding with another high-rise building. That we need to consider the shelter effect to reduce the wind load. So we need to have a very precise surrounding building. We also use the Hong Kong open data to capture the information of the surrounding building, and then we use our in-house software called ETA Hong Kong Wind to compute the wind load for each direction. And this is how we capture the information from the CSDI to our Revit model, and we can use this Revit model to compute the wind load. So next chapter is about the challenge. I just share some feeling or some idea about the next challenge, because we can see that especially this year, the ChatGPT technology and the AI and machine learning technology is very fancy this year, especially some architecture or the CG expert. They have nowadays they use a lot of AI and machine learning to produce the architectural drawing. Is just like 1 minute or several minutes, you press one click, and then it can generate a lot of different schemes. This is for architecture, but Fortunately for our structure, there are no such as AI or machine learning program like ChatGPT or other program can auto-generate the structural scheme or the structural drawing. But I think in the future, they will be must be a item in the future. But we need to face this challenge. And we can see that nowadays, like BIM integration and the automation, like automation is especially the parametric design, we can see that the grasshopper is developed so fast nowadays. So it's a challenge or it's a chance for us to catch up, and we can use this one as the tool to minimize our man hour and increase our efficiency for the production of the structural design. And the other challenge is nowadays every government, also Hong Kong government, also have some open data for the structural design or the geotech design. But nowadays they have data, but we just start to learn how to use this data. You can see that we can use the open data to compute the wind load and to use for our foundation design or the slope analysis. But this just a small part of the forest. I think is in the future is a very big picture how we can use this open data combined with AI and machine learning to make a wonderful tool for our engineer analysis in the future. Also, this also called the data collection and analysis, because now the data, we can use the data now, but we cannot use the big data. When we call it the big data, we need to collect the data and we use the machine learning method algorithm to analyze the result. And I think this is the challenge and in the future. So we need to focus in this technology. Okay, the future development for our ET system, we can see that nowadays, this year happened is we use the ET structural software to develop the redevelopment, use the same theory, but we transfer to another issue to run the foundation analysis. So we invent ET foundation. It's the same, but it's the same architecture in the software, but we can use for the different aspect. You can see that in WSP, there are a lot of aspects, not only the structure and the foundation. Also, we have bridge, tunnel, and traffic, environment, and geotechnical, and sometimes MEP like drainage. We can also use the ETD technology to invent some new tool to automate the design and the analysis, especially to produce the drawing, because the drawing and the model is our output, the main output of the engineer design. And the other one is we can, in the ET structure program, we have the BIM automation. And this automation tool can also transfer to another aspect. And recently we have the ET railway. It's used the same architect to produce the railway automation tool. You can see in the introduction. And geometry is for the open data. In Hong Kong, we understand the CSDI have a lot of data, but we don't understand in the other country or in other company or WSP, if they have some wonderful open data, we can try to use our inventory to connect this data. In the next stage, maybe we have some traffic inventory to collect our WSP traffic data. This is very powerful tool in the future. Nowadays, the traffic data is separate for each zone. We cannot see the connection. But if we can use the traffic inventory, we can use like a big data analysis method, we can find the traffic, maybe find some traffic problem, or we can find some solution. And this is the future development of our ET system. Okay, I think I finished this part, so I hand out to my part to Cecilia. And Cecilia will answer some question from you.
Yes. Thank you, Dino and Cecilia, for a fantastic presentation. I will mention again the housekeeping items. The presentation slides are available to download in the handout box, and you can continue to log your questions in the question box on the GoToWebinar control panel. I will start with the first question. How does the WSP ETE software solution couples or integrates with geotechnical finite element modeling like Plaxis or other similar tools?
Dino, I will answer and then maybe you can support later, okay? And traditionally, you will have to obtain the GI report and then manually input the soil information into the Excel for the initial analysis. For example, to deduce the soil parameter. But in Hong Kong, government authority already own a data bank which aim to share some open data. For example, we're talking about the GI data in AGS format. But it doesn't matter, even in your region, maybe you don't have this AGS format, you can manually make those information into an Excel file and then use our own Revit API to translate this data into 3D model, and then you will get a preview of the subsoil, and then to transfer this data to other analyze software such as the Draw Studio or the Plexus, etc. That makes you easier to get the full picture before working on the substructure design. It also saves some time for the data preparation to check which one you have to use in different software.
Yes, and we have some new development about the slope analysis. Nowadays we can import some information to the Revit program, and then we can use Revit program, use some API from the Revit program to generate the model directly from the Revit to the GeoStudio Slope W, and we can use this Slope W to run the analysis. And we found that Slope W has a lot of limitation of input some information like soil nail. So we also working on the soil nail optimization in this program. But nowadays it is still under the development. So we will maybe in the future we'll have some introduction of this program. It's about the slope analysis.
Thank you. The next question is, once the drawings are produced, will the tool update the drawing when there are changes, or does it generate new drawings?
Cecilia, you answer this question?
Okay. Actually, it will not generate new drawings. It can select either supersede or you can save to a new file to have two sets of different drawings. So it should be no problem.
Yeah, in our ET program, it has a lot of graphic user input interface. It allows you to input the reinforcement for each column. If you don't, you have some increasement of the reinforcement or rebar area based on the area from the calculation, you can define for every column have the different arrangement of the rebar. So the program can, according to your rebar input, to generate the update drawing. Yeah, it's okay for our, we can accept a lot of change in the process. We just not to regenerate the new drawing.
Thank you. A question about Revit. When exporting from Revit, does the ETE use the physical model geometry or the associated analytical model?
When the model export from Revit, it actually uses the physical model geometry. I mean to import into the ETE.
I think there's nowadays the ET is use the geometry model, but because the geometry model is linked with the associated with the analytical model, so in the plugin we just read the analytical model location to define the beam and column central line. So I think this central line is for the analytical model, but the other information like the column size, column like a column beam, the line load or the slab line load is from the physical model. So it will need these two information. We can generate the model to ET and to ETABS.
Thank you. I will take another question. Could you provide more information about AI approach for boreholes interpretation?
Oh, actually, this this introduction is in the previous SNET and Learn or icon. I think it's it's icon the introduction. Or the I can have a little bit introduction of that this AI approach of the borehole integration. And because at the very beginning, we have, for example, in that project, we have the 400 borehole, and this borehole has the CPT test. And this CPT test, we need to use this test result to identify which soil this layer belong to. And for each block, you need, for example, like a 3 hour or 4 hour to terminate which the full length, the information of the soil property. But at the very beginning, we had a limitation of the hour to work out the whole site. I think that site is the airport site, and we just have a little bit time to identify the soil property for like a 440 blocks. So we use the AI machine learning method approach. I think it's a neuron algorithm to compute this 440 to 100. We choose 40 as the sample, and the other 40 is the result checking, and then we use the machine learning algorithm to make sure this algorithm, the factors have meet to the target, like 95% accuracy. And then we use this model to apply to this 400 CPT test results. So we can use AI to identify all the soil property of this 400 block, or even 600, even 1000. And this is the short introduction of this AI technology. Yeah. You can see this introduction in the other video in our the WSPA icon video. Yeah.
Thank you. I will take the last question. We have a lot more questions. Apologies, we don't have time to cover them all, and the presenters will come back to you via email. I will take the last question. Does ET have a model coordination feature or clash detection function?
In ETE we have some coordinate feature is for, like, for example, that the shear wall itself, like the X direction wall and the Y direction wall, we just make sure they will not crash. We just, for example, we just allow X direction wall is continue, and the Y direction wall will cut off, so we can make sure the wall will not overlap. We have this function, and the other function, when we generate the CAD drawing like a framing, we just can cut off the beam end from the column, because we can compute the beam and column relationship to notice which one is overlap. We just cut out a beam overlap part. So we have some coordination calculation in the ET when you generate the CAD drawing. But when the ET gen the Revit model, because the Revit model itself had this crash detection function, so we just can ignore this one. But sometimes for the very complex steel structure, even we just import this model to Revit, the Revit needs some modification for the the beam or brace and column intersection part, because for the computer, they don't understand which one is main beam or which one is main member, which one is secondary member. So sometimes we also need some modification in Revit.
Fantastic. Cecilia, anything to add on this one, on this question? Okay. Thank you, Dino and Cecilia, for a fantastic presentation. Thank you all for joining us today. We're a bit over time, so apologies for this. And thank you for joining us. We hope to see you in our upcoming webinars, and all additional questions that were answered here will be answered directly by the presenters. So thanks, everyone. Have a wonderful day.
Thank you.